When we think about our planet's oceans, we tend to picture them as these vast, ancient, unchanging spaces. But the truth is, they're in constant motion. They're part of this incredible, slow-motion geological drama that's been playing out for millions of years. And honestly, the story of how they're changing is just fascinating.
I mean, just look at it from space. It's so obvious, right? Our home is an ocean planet. Over 2/3 of the entire surface is covered by this incredible expanse of water. It's really the defining feature of our world. So, we all learned that our planet has 5 huge oceans. You get the Pacific, the Atlantic, Indian, Southern, and Arctic. But here's the kicker. They are not static. Right now, as we speak, one of them is actually expanding, literally pushing continents apart. While the biggest one of them all is, well, it's slowly vanishing. So how on earth is that even possible?
To get a sense of this, just look at the staggering scale of the Pacific Ocean. It makes up 47% of our ocean area. That is almost as big as all the other oceans combined. It covers more than 1/3 of the entire planet. Now keep that colossal size in your head because it makes the fact that it's disappearing even more wild.
Okay, so let's start with the one that's growing, the Atlantic. You can think of the Atlantic as this place of constant creation, like a geological engine that's building brand new parts of our world right from the bottom of the sea. So the secret to the Atlantic's growth is this incredible feature called the Mid-Atlantic Ridge. Now get this, it's the longest mountain range on the entire planet, and it's almost completely underwater. Picture it like a giant seam running right down the middle of the ocean. And along that seam, molten rock from deep inside the Earth is constantly bubbling up, cooling off, and forming brand new ocean floor.
And that process, that creation of new floor, is pushing North and South America away from Europe and Africa this very second. So how fast are we talking? Well, about 1 inch, or 2.5 centimeters, every single year. That's roughly the same speed your fingernails grow. I know, it doesn't sound like much, but when you let that happen for millions of years, it's more than enough to create an entire ocean.
And here's what's really cool. In a few places on Earth, like Iceland, the Mid-Atlantic Ridge is so massive that it actually rises right up out of the sea. So what you're seeing here isn't just a cool rock formation. It's the ridge itself. It's the engine of creation, literally breaking the surface for us all to see.
All right, now let's flip the script and head to the other side of the world, where we find a totally different story. If the Atlantic is all about birth and creation, the Pacific story is one of consumption, and it's all framed by the famous and very volatile Ring of Fire.
So here's the big paradox. The Pacific is the undisputed king of oceans. It's the biggest, it's the deepest, it has over 20,000 islands. And yet, while the Atlantic is busy getting wider, the Pacific is steadily shrinking. Now, here's the most important piece of the puzzle. Our planet isn't actually getting bigger. So it's a zero-sum game. For new ocean floor to be created in the Atlantic, some of the old floor has to be destroyed somewhere else. So while the Atlantic has that spreading rift that creates floor, the Pacific is lined with these super deep trenches where old ocean floor gets forced down, diving underneath the continents, and melting back into the Earth's mantle. Creation versus destruction. And when I say these trenches are deep, I mean they are unbelievably deep. The Mariana Trench, out in the Pacific, is the deepest single point on our entire planet. It plunges down almost 11,000 meters. To put that in perspective, that's deeper than Mount Everest is tall. This is basically the planet's giant recycling program in action. So as this huge plate of ocean floor gets consumed, it melts, and all that molten rock and pressure needs to go somewhere. It fuels the massive chain of volcanoes that encircles the entire Pacific Basin. And that is why we call it the Ring of Fire. The shrinking of the Pacific is directly responsible for some of the most powerful earthquakes and volcanoes on Earth.
Whew. So, now that we've covered the huge drama between the Atlantic and Pacific, let's do a quick global tour of the other 3 oceans. Because each one has its own really unique personality.
First up, the Indian Ocean. This one's pretty special because it's mostly surrounded by land in the northern hemisphere, which actually helps make it the warmest ocean on average. These warm, tropical waters are the engine for the powerful monsoon winds that completely define the climate and the lives of billions of people across South Asia.
Way up at the top of our world, you'll find the Arctic. It's the smallest and the shallowest of the 5. For pretty much all of history, it's been this vast frozen sea, a unique ecosystem built around a permanent cap of sea ice. But as we all know, that ice is now shrinking fast, which is opening up new shipping routes, but also seriously changing global climate patterns. And finally, let's go to the very bottom of the planet, to the Southern Ocean. This place is a wild, cold, stormy sea that just whips around Antarctica. But what makes it so absolutely crucial is that it's the only ocean that connects to three others: the Atlantic, the Pacific, and the Indian. It acts like the main hub for all the currents that connect our entire global ocean system.
So we have 5 oceans, right? Each with its own name, its own character. But this idea that they're separate bodies of water, that's really just a human invention.
The reality is, despite the different names we've put on our maps, they aren't separate at all. They're all connected. They flow into one another, forming a single vast body of water that's constantly circulating heat, nutrients, and life around the entire globe. Seriously, what happens in one ocean will eventually affect all the others.
And all of this leaves us with one heck of a final thought. This whole process of creation and destruction, it's happening right now, under our feet. So if we could hit fast forward, say, 200 million years into the future, what would our blue planet even look like? It would probably be a world we wouldn't recognize at all.